Okay, so we're talking about binomial radical expressions. Just like you combine like terms, like if you saw this problem, it'd be 5x, 2x plus 3x. So to combine like radical terms, a couple things have to be the same. The radicand, the number inside, has to be the same. The index or root has to be the same. Those are both square roots of 5. So if I give you 2 square root of 5s, give you 3 more square root of 5s, how many square root of 5s do you have? You have 5 square roots of 5. So they're pretty easy to add as long as everything's the same as far as the number inside, the radicand, and the index. Now these two, they have the same index. They're both square roots. One's 45, one's 20. So what you have to do in this kind is you kind of hope and trust that they will simplify if you factor them. So I'm going to do menu 2, 3, factor 45, and menu 2, 3, factor 20. So the factorizations of those, that's really square root of 3 squared times 5 minus square root of 2 squared times 5. Well, that's just really the 3 comes out. The square root of 9 is 3. So 3 root 5 minus 2 root 5. Now I can add up those terms. 3 root 5 minus 2 root 5 is 1 root 5, or just root 5. So that's kind of the step you have if they don't match to begin with, and you're kind of trusting or hoping that they might match. And so as long as these are not prime numbers, I would think about, let's try to simplify them, and then maybe they'll go together. So menu 2, 3, 8, menu 2, 3, which is factor 48. Okay, so I need square root of 2 to the third. So I have a pair of 2's with a 2 left over. So this would be 2 root 2 plus, let's see, this would be kind of weird. So 2 to the fourth, that's really 2 squared times 2 squared. That's 2 times 2, which is 4. So there's 2 sets. So 2 times 2 times root 3. And unfortunately, these two do not combine together. That's as simple as you can get. So they don't go together because the radicand, the number inside the radical, is not the same. So we cannot add or combine those terms together. So it doesn't always work. Many times it does, but it doesn't always work. So the cube root. So let's factor, these are not prime numbers. So menu 2, 3, 54, menu 2, 3 of 16. So 2 times 3 to the third. So this first one is a 3 times cube root of a 2 that's left over, plus. So there's 4 2's inside. You need a group of 3, and then there's 1 left over. So it'd be 2 times the cube root of 2. And these add together nicely. 3 cube roots of 2 plus 2 cube roots of 2 is 5 cube roots of 2. It's times there. Multiply binomials, you know how to do that. You FOIL it. 15 outside would be plus 6x. Inside is plus 5x. Last is plus 2x squared. Put it in the right order. So I'm going to have 2x squared plus combined like terms 11x plus 15. You know how to do that. I went kind of fast, but I think you know how to do that. So with radicals, it's not that much more difficult, but it is a little bit more work. So 3 times 5 is 15. Plus outside would be 6 root 7 plus 5 root 7 plus 2 times the square root of 49. I'll simplify that in a minute. So it's going to be 15 plus 11 root 7. And 2 times 7 is 14. So maybe, 29 plus 11 root 7. And I just kind of, that's our perfect square. So 2 times square root of 2 times 7 is 14. And now we get some serious radical multiplying. So this could be 2 root 3 times 2 root 3 is 4 times root 9, which is 4 times 3, plus 10 times root 21 minus 10 root 21. Oh, that's interesting. Minus 25 times 7 or root 49. So this ends up being 12, that is 0, minus 175. So that'd be negative 163. And conjugates are very similar to difference of squares. The conjugate of a minus b is a plus b and vice versa. So those are conjugates of each other. And we use this to simplify the radical. When there's, this is different. I think the other day we rationalized the denominator. We still don't like that irrational number of square root of 5 in the denominator, but we're going to use a different technique. Because it's a binomial, we're going to multiply it by the conjugate. The conjugate of a plus b is a minus b. So the conjugate of 2 plus square root of 5 is 2 minus square root of 5. You might say, well, why is that going to work? Well, let's watch what happens. Remember, this is difference of squares. When you FOIL this, the inside-outside is going to cancel out. So in the denominator, all I really have to do is first times first, which is 4, minus last times last. Square root of 5 times square root of 5 is equal to 25, which is 5. So now our denominator is negative 1. I like that a lot better than square root in there. 1 distributes there, so we get 2 minus square root of 5, same thing really. 2 minus square root of 5. The other thing we don't like in the denominator, really don't like that denominator to be negative. So you have a choice. You could either put the negative out front or distribute up top. So I'd just say negative 2 plus square root of 5. And there's no need to put it over 1. Divided by 1 is the same thing. So I just change the sign of everything in the numerator and we're good to go. Okay, last one, kind of a tougher one. So the conjugate of that would be 2 root 3 plus square root of 7. 2 root 3 plus square root of 7. When you FOIL that in the denominator, all you have to do is first and last. So 2 root 3 times 2 root 3 is 4 times 3. And then minus square root of 7 times square root of 7, which is 7. So we have 12 minus 7, which is 5. And I'm not going to multiply that out. And the reason is because I think I can cancel here. I kind of see what's coming. Times 2 root 3 plus square root of 7. 10 cancels, you get a 2. So you end up with 2 times 2 root 3 plus square root of 7. You could distribute that if you want. That would be fine as well. That's it. That's your lesson. Wow, that was fast. Since we have a little extra time, let's go ahead and do the PSAT today. So this one, looking at a table, does that data look linear or exponential? That's the first question. You can either eliminate A and B or eliminate C and D. So see what the pattern is for X. So X seems to be increasing by 5s as it goes. And Y seems to be not increasing by a constant amount. It seems to be going up by 900, then 9,000, then 90,000, then 900,000. So it's not going up in a linear fashion. It's not increasing by a constant or linear amount there. So it's definitely one of those. Is it growing? Yes, it's growing. So I think the answer would be C. But I hope you can handle that kind of problem as well.